Hello everyone, so welcome back to our channel, that is AI Next Generation. In the previous 5 video, I think you are clear with the things. We already have done the training, we already have done the creating our model. So in the previous video, I just said to you that we will see the accuracy, training accuracy and validation accuracy in the next video. Okay, so it was just taking some time, 5 minutes to 10 minutes to train our model. So you are able to see we are getting a train accuracy as 97% and validation accuracy as 92%, which is the really good model. You are just building the model because your both training accuracy and validation accuracy is really high. Okay, now the main task of this video is to take an image, that can be any image, but that should be related to the chest x-ray. Means you are just downloading from whether from the Google, or you are just using already you have just separated for the test data, the 16 image you have just separated for the test data. You can just see here. Okay, 16 image you are just going for the testing your data. Okay, so whenever your model has been trained and finally you want to see how your model is performing on the real world data set. Okay, so you can just fill out the chest x-ray image and your model will predict whether the person is suffering from the viral, or whether the person is suffering from the particular COVID, and whether the person is suffering from the particular, we can just say normal. It's there is no suffering from that. Okay, so our main task is to see how our model is performing on the real world data set. Okay, so for that, what you can just do, you can just create a one method. Okay, one function for that. So you can just write def, you can just zoom in. Okay, you can just write gem and then predict image. Okay, image, and here you will just pass the two parameter. One will be the image and then second parameter is the model. Okay, the train, we already have been trained our model. Okay, so now after that, what you have to do, okay, you have to unexcuse the data set. Mean unexcuse the image. What does it mean? You are just passing the one image. Okay, but you have to pass in the form of n comma dimension of that image. Okay, n is basically your the batch size, and then after that you have the number channel, height and width. Okay, this is how you are just accepting. Okay, this is the way the model expect. Okay, so you should apply for that. So what you are just doing, you are just adding one more, you are just adding one more dimension, that is a batch size as a 1. Okay, for that, what you are just doing here, you are just writing here img, okay, dot unskews. Okay, unskews, for that you're just writing this one, the unskews, and here you are just passing the things, you are just adding one more dimension for that. Then after that, what you are just going to do, you will pass this thing to the model. Okay, so the similar way we already done, you have seen in the training part. Okay, now your model will give you in the output layer, we have 3 neuron. Okay, so in the 3 neuron you will get some output. Okay, you will get some values, and which neuron will be fired, which has the maximum number of value inside that neuron. Okay, so how we are going to do, you have to just write pred equal to torch.arg max. Okay, you are just writing torch.arg max, and here you are just passing the y, that is the, this is the final, and then after one dimension we are just passing as a 1. Okay, so clear. Now what you will just return, which particular neuron has the output, you want to give the name of that. Okay, it will just return the index of that. Okay, so how you can just give the name, just write train underscore data dot classes. Okay, classes, and then after that, then classes, it does mean that I can just show you, already we have just defined a verb. So whenever you just write train.data.classes, okay, so you are just writing, it will be in the form of 0, COVID, normal and viral. Okay, if the index is 0, okay, if they predict return as 0, the maximum value you are getting for the COVID, that is it in the 0 index. Okay, so you want to get the label of that. Okay, so this is how you are just finding. Here you can just keep the predict, because pred torch.arguments will return you the index of that. Okay, clear. So I don't think so you have doubt in this. Okay, now the next step, now you will see the image, you will take from the test data and you will see for the image. Okay, so now what you are going to see, so image comma level, it will return 2 parameter. How? Whenever you are just taking the test data. Okay, test data, and you are just selecting any random value in a random image. Okay, the random 1 2 3 anything. Okay, and then after that, what you are just going to do, you want to plot this thing. Okay, plt.imso, and then after you have to just write the img dot, what we have done, the permit, we are just changing the axis of that. Okay, permute, and you are just changing the axis from 1 comma 2 comma 0. Okay, so you don't have to change it back to the toss to back to the numpy to visualize. Okay, you are directly changing the axis for that. Okay, in the x and y form. And now you want to see print, you what will be the actual. Okay, the actual label. Okay, actual label for that, and also you will have also the predicted label. Okay, so actual label is basically the what your model has been predicted. Okay, the what your model has been predicted, that will be of train data. From that you are just taking this index only, that's it. Okay, dot classes. Okay, that's it, and you are just taking the label of that. Okay, so test data, you have this label, you have the label, you have image, and you have the label. Every image has the label. Okay, that is the actual, but you want to see something from the prediction part. Okay, so prediction, what you are going to use, prediction label, you can just say you are just writing yeah, you are just writing this particular function. And how you are going to write this function, you are going to write this predict image. Okay, and here you are just passing which parameter, you have to pass two parameter. Okay, the first is the image, the already this image, and comma the model, we already have the model. Okay, let's see what will be the output. Hope so. Yeah, hope so. It's running. Yeah, it's running. So actual level was the viral. Okay, and the actual and the prediction level is also a viral. So your model is giving a good accuracy. You can just do whatever, you can just do copy paste of this, and you can take any another image. So you are able to see. I can just take 10. I'm just taking random. Okay, so it's like, yeah, it's COVID, actual label is a COVID, means that particular image is a COVID image. Okay, but also your model is predicting also a COVID. Okay, so because your model accuracy was 97%, it will give you a good accuracy. Okay, even you can just do for the another image, you want to see something that's related to the 15, I'm just searching. Okay, so this is the normal, and it is also predicting as a normal, because this x-ray is for the normal, and your model is also predicting a normal. So you have just done for the all the three, the normal, the viral, the COVID, and the viral. Okay, so this thing is really easy. You are just predicting this thing in the real world scenario. You can just pass any chest x-ray image and directly to the model, and then after you are able to see what your model has been predicted, and you can just match with the actual. If your accuracy of the training accuracy is 97%, and the validation accuracy more than 92%, then your model is really good. Okay, so yeah, so that is for the whole series of the particular COVID-19 chest x-ray detection. So I think you are clear with this particular. We have just gone through about the data set, and then after we have gone through the libraries we have used, then after we have gone for the image transformation, then after we have gone through the data loader image folder, then after we have just visualized the data set, then after we have gone for the particular building our model, then after we are just training our model, we have just developed a function, that is a training function. Okay, so then after we are getting some accuracy as 97% and 92% for the both the training and the validation, then now you are just building a one method. So you want to see that particular image in real world scenario, real world image, any image you are just passing that's related to the chest x-ray. So you are able to see whether the person is suffering from, the patient is suffering from the COVID or normal or it's viral. Okay, yeah, so that's all for this whole series related to the COVID chest x-ray detection. Hope you like our video. Please subscribe our channel. Thank you.